Welcome to lesson 12.5. We'll be solving quadratics by factoring today. So let's begin with our bell ringer. Let's refresh our memory on factoring quadratics. We're going to use this skill today. So in the first case, we have an a value of 1. So 1 times negative 20 is negative 20. So we want two terms in the middle. They're going to multiply to negative 20. But add to my b term of positive 1. So we're going to rewrite this as x squared negative 20. So that's going to be 5 times 4. We want the 5 positive. We need one positive and one negative to get a negative 20. And then negative 20 still on the back. Then we're going to treat these two as separate binomials. So in the first case, I'm going to factor out an x. And then when I factor that out, I get x plus 5. In the back, I'm going to factor out a negative 4 and get x plus 5 again. So this becomes x minus 4 times x plus 5. And then the second problem, I have 2 times 7 is positive 14. So I want two numbers that are going to multiply to give me a positive 14, but add to give me this negative 15. So that tells me they're both going to be negative. So let's go 2x squared. Looks like it's going to be 14 and 1. So negative 14x minus 1x plus 7. I factor the first two terms as though it were a separate binomial. And so I go 2x is coming out of both. That leaves me with x minus 7. And in the back, I'm just going to factor out a negative 1. And that gives me x minus 7. Remember, these two have to match if my factoring is going to work. So I'm left with 2x minus 1 in the front and x minus 7 in the back. So your factoring skills might be a little bit rusty, but you're going to get plenty of practice with them in this particular section. So today, as mentioned, we're going to be solving quadratics, by factoring. So before we do, we need to understand something. There's a product in math called the zero product property, and it's pretty common sense, but I want to talk about it so you understand why the factoring method works. When you have two numbers, a and b, if you're multiplying those two numbers and they equal 0, then that means a has to be 0 or b has to be 0. So there's no way to get 0 when multiplying two numbers unless you have a 0. Okay, for example, let's use that now. If I know that x minus 4 times x plus 3 equals 0, then either x minus 4 equals 0 or x plus 3 equals 0. And when we're solving quadratics by factoring, we use this property to separate these into two small equations, and then we treat them as though they're just separate equations. So if I was going to solve the left, I'd add 4 to both sides and get x equals 4. X plus 3 equals 0, I'd subtract 3 from both sides and get x equals negative 3. So my answers then are x equals 4 and x equals negative 3. So let's try one here. This means that x plus 7 equals 0. If I subtracted 7 from both sides, I get x equals negative 7. Or x minus 1 equals 0. Add 1 to both sides, and x equals 1. Here's another one for you. You won't always get whole number answers. So in a problem like this, 2x plus 3 equals 0. Subtract 3 from both sides. Then you have to divide by 2. And you get negative 3 over 2. Or 3x minus 4 equals 0. Add 4 to both sides. Divide by 3. And you get 4/3. Okay, so that's the property that we're going to use after we factor. So let's take one right from the beginning here. If it's not already factored, then we need to go ahead and factor it. So in an example like this, let's factor it. We have an a value of 1. So 1 times negative 48 is negative 48. I need two numbers in the middle that are going to multiply to give me negative 48, but add to give me negative 8. So the possible combinations are, 48 and 1, 6 and 8, 12 and 4. I like 12 and 4 because I can go x squared minus 12x plus 4x, and these two numbers together will give me my negative 8. Okay, so then I factor the front, x times x minus 12, factor the back, take out a 4, I get x minus 12. So then x plus 4 times x minus 12 equals 0. And now I apply the zero product property that we just talked about, and I know that x plus 4 equals 0. If I subtract 4, I get x equals negative 4, or x minus 12 equals 0. Add 12, and x equals 12. So those are my two answers. Let's try some on our own here. Here's one for you to try. Pause the video, give it a shot. Okay, in the first case, an a value of 1, a b value of 1. 1 times negative 20 is negative 20. So I'm going to need two numbers that multiply to negative 20 that add to my 1. That looks like it's going to be a positive 5x and a minus 4x. So then I factor out an x plus 5. In the back, I'm going to factor out a negative 4, x plus 5. So x minus 4 times x plus 5. Therefore, x minus 4 equals 0. So x equals 4. Or x plus 5 equals 0. And x equals negative 5. There's another one for you to try, a little bit more difficult. Pause the video. Okay, so the first thing I need to do, I need it equal to 0 because I'm interested in where my y value is 0. The x is where my y value is 0. So I'm going to subtract 21 to start with. 3x squared minus 2x minus 21 equals 0. Then I'm going to factor. So my a value is 3. My c is negative 21. 3 times negative 21 is negative 63. So I need two numbers that are going to multiply to negative 63 and add to negative 2. So the combinations that give me negative 63, 63 and 1, 9 and 7 comes to mind, and I think 9 and 7 is what I need. So 3x squared, we want the negative to be the 9, positive the 7, so that when we add them we get our negative 2, minus 21 equals 0. Then I factor the front, 3x times x minus 3, and in the back I'm going to factor out a 7. I get x minus 3 equals 0. So that means 3x plus 7 equals 0. Let me go back here just a sec. Jump the gun on that just a little bit. 3x plus 7 in the front, x minus 3 in the back. That means either 3x plus 7 equals 0, subtract 7, 3x equals negative 7, divide by 3, x equals negative 7 over 3, or x minus 3 equals 0, add 3, and x equals 3 are my two answers. Thanks for listening. See you in class.